Hello and welcome back friend. I hope you will be doing great. Now we are in class number 8 that is related to network. So without delay, let's get started. Learning objective. So following thing we are going to learn: type of network in ME engine, network configuration, network status screenshot, cabling map, network reconfiguration, familiarization of all symbols, and last, troubleshooting. Now we are going to start with network. Network here in the context of ME engine, the network is of three types. First, network among all MPC including MOP, network between RCS and EICU, network between SU and PMI. Both of these network configuration we have already seen. So in this chapter we will focus on network among all MPC including MOP. Next question is why network is needed. In order to establish the communication among all MPC, MOP, RCS, PMI to share the information data to each other. Why data exchange is required? To cross check. That means if some data is sent to various MPC, then with help of network cable, both MPC can check that whether the data received is correct or not. Next, disseminate data. That means if data received by one MPC need to be sent to other MPC, then it can be sent with the help of network cable. To give order to other component, this we can understand with this simple diagram. Suppose this is a solenoid valve which is connected with number 2 MPC, but I want to give command through number 1 MPC, then I can give through the network cable. This picture depicts what all components are connected with main network cable A and B. We can see here that MOP A, B, EICU A, B, ECU A, ECU B, SU and all CCU are connected with this network cable A and B. These whole components are categorized in the three parts. That is, first one is bridge, that is related to telegraph handle and remote control system. Second one is MOP A, MOP B, EICU A and B. These are placed inside the engine control room. And third one is LOP. This one is LOP, ECU A, ECU B and all SUs, all CCUs, CWCUs, SCUs all are placed on the engine itself near to the maneuvering platform. Now next question is why two networks is given, network A and network B. Answer is just for redundancy. That means if any one of the network doesn't respond, then other will take care of the operation of the engine. Now next, in this picture I am going to show you where the network cable A and B are connected with the MPC. So this is channel number 65 and it handle network A. This is channel number 66 and it handle network B. Now here in this picture, these black wires are the main network cable, and here this is also a network cable as I have already discussed before. This network cable establishes communication with the remote control system in case of EICU A and B, and establish the communication with PMI in case of SU1. This is the picture of MPC10. Now I am going to show you where the network cables are connected in the MPC10. So here you can see these are the network cable and these are also connected with the channel number 65 and channel number 66. This is the picture of network cable configuration showing how network A and B cables are connecting various MPC and MOP. So let's start with network cable A. Here you can see network cable A is shown with the red color and network B is shown with the blue color. Network A start with the MOP B with 120 ohm termination resistance, and it goes all along to the various MPCs and MOP and get terminated at ECU B with termination resistance 120 ohm. In the same way, network cable B start from the MOP A with termination resistance 120 ohm and it passes all along through various MPC and MOP and get terminated to the ECU A with termination resistance 120 ohm. Now let's talk to channel number 65 and 66 plug. Here you can see that there are three wires called A, B, C. The terminal C is called shield. This is nothing but a ground wire. which is shown with the yellow and green color. Next, the terminal A and B. This white and brown color wire is showing the wiring for terminal number A and B. Now here I have one question for you. By seeing this picture, can you make out that what actually it is? It is issue A or issue B? Let me answer for this. By seeing this MPC, we can make out that this is channel number 65 and this is channel number 66. Channel number 65 is responsible for network configuration A, and also we can see that there is a termination resistance fitted in channel number 65 and it is handling the network configuration A. So out of these two, issue A and issue B, this issue B is actually this one because it is handling network cable A with termination resistance 120 ohm. So here we have seen that how a network cable is configured in the MPC. Now we are going to see the same thing in the MOP. So here this is the picture of back side of the MOP. Now here you can see that 120 ohm resistance is fitted in the network cable A in the MOP B and in the network cable B in MOP A. So can you tell me that where the 120 ohm resistance is fitted? So answer is that when we will open this metallic cover of this plug, then you will find the termination resistance is placed like this. Now next move to another topic. So here we are going to talk about the network status, which is available in the maintenance window, that is a part of the MOP screen. Now in this picture we are going to talk about the two things, that is the observer and observed. The simple meaning of observer is that the data which is sent by any MPC, then this will be called the observer, and the data which is received by any MPC, then it will be called observed. I can give you a simple example by which you can understand. Suppose MOP A has sent message to MOP B that are you there? In that case, MOP A becomes the observer and MOP B becomes observed. Another example, MOP B is sending message to MOP A that yes, I am here. Then MOP B becomes observer and MOP A becomes observed. So I hope that this is clear, that what is observer and what is observed. Now here you can see that in observer panel all MOP and MPC are placed, as well as in observed panel also all MOP and MPC are placed. Now related to observer and observed, we can understand it by a simple example, that at a given point of time, suppose MOP A has become observer, then the very next time it will become observed. So that is how all this MOP and MPC works. Now here one thing is difference between this observer and observed, that in this observer panel you will find that for each and every component, either MOP or MPC, network A and network B configuration has been given, but in the observed panel only the component has been given. That means here you can see only CCUs are mentioned, but here individual CCUs network configuration are also mentioned, like AB, AB, AB. Now next I am going to talk about this symbol. This symbol is saying that this MOP, that means this screenshot has been taken from the MOP B. Here it is written MOP B. If it would be taken from the MOP A, then this symbol would have present over here. Now here I am going to talk about this symbol. This symbol is showing that not relevant. Meaning of this, that a single component cannot communicate with itself. Instead, it can communicate with other component. That means here MOP A cannot communicate with MOP A, but it can communicate with MOP B. So here in MOP B column you can see tick tick is given. That means communication is okay. Now I am going to talk about this symbol OK. So here OK means these two components are communicating with each other. For example, if I take here this tick, that means I can say that ECU A network B is communicating with ACU2. Another example, meaning of this tick is that ACU3 network A is communicating with CCU2. I hope this is clear. Now we are moving to our next topic, that is cable mapping. So this is very important. It will give you a lot of scope to rectify the network related issue. Here it is written cabling map. Now we are going to see what is the meaning of cabling map. The simple meaning of cable map is that what all services or equipments are connected to a particular network cable, that is A and B. That means it is showing that what all components are connected with network A and what all components are connected with network B. This cabling map is mainly equipment oriented rather than cabling. That means it will tell you the status of equipment rather than the status of the network cable. This you can understand by the simple example. In this picture I am just showing you again that you can see here, this is network cable A, that is in red line, and it is connected with various components like MOPB, EICUB, EICUA, etc. So the meaning of this cabling map is that if I consider this network cable A, then what all components can I see? So I can see ECUB, SUA, SU2, all CCUs, ECUJ, all MOPs, EICUs, etc. And as I told you that this is component oriented rather than the cabling oriented. That means if something goes wrong with any component, it will highlight over here that what component is missing and what all component is facing issues. For example, if I get this message, then I will understand that ACU1 has some problem. Another example, if I get this symbol, that is no reply single channel, then I will understand that ECUA has some problem. So I will check ECUA. Another example, if I get this symbol, that is no communication, then I will understand that ACU1 has some problem and I need to check the SU. That is the whole idea of the cabling map. So all alarms you will get over here, and by seeing this alarm you will able to identify the exact location of the component which has problem, and you will go straightway and check that component. We will discuss later what all issues can arise and how will you tackle the problems. Now here we are going to talk about the network reconfigure. Here you can see these are the digit 33 is written. These are basically the counting of the reconfiguration. Now we are going to see what is network reconfiguration. Changing the order of data to be sent to other component in case MOP MPC facing difficulty. That is called the reconfiguration. This you can understand with the following example. Like suppose ACU1 is there, which is sending data, hydraulic pressure, swash plate angle, inlet pressure. That means first it will send this one, then it will send this one, after that it will send this one through the network cable to ECUs and all CCUs. And if it is getting difficulty, then it will try to reconfigure the network and it will change the order of this data. So here you can see first it is now sending inlet pressure, then it is sending hydraulic pressure, then it is sending swash plate angle. Here it was something different, here it is something different. If still it is facing problem, then again it will change the order of the sending data. Now it will change to swash plate angle, then hydraulic pressure, then inlet pressure. If still it is facing problem, then again it will change order of the sending data, that is swash plate angle, then it will send inlet pressure, then hydraulic pressure, and so on. That means each time if it is reconfiguring the network data, then count will increase by 1. I hope this is clear. So you can see here the reconfiguration counting has increased. In the network A it is showing 54 and in the network B it is showing 52. It is not a big issue, it is a normal thing, but if it is increasing with abnormally high rate, then there is a problem. Now here we are going to see the tour of network cable. So here this is a small video. This is issue B. Then this is issue A. This is SU1. This network cable is here for PMI. This is SU. This is the network cable. SU3. And these are CCUs. CCU5, CCU3, CCU1, CCU4 and CCU6. So that was a small video for your reference, that how the network cable is connected among all MPCs. So next chapter is communication related problem and their possible solution plus symbol familiarization. Here we are going to discuss all symbols in detail. Our first symbol is no reply single channel. So here we are going to understand what exactly it is. In this network system there are two network cable A and B. So simple meaning of this is particular MPC MOP means channel number 65 or 66 is not communicating with network channel A or B. That means either of the channel is not working for any particular component. That means suppose this is CCU1, and if CCU1 is not establishing communication through the network cable A, then this alarm will appear in the CCU1. I hope this is clear. Now we are moving to our next symbol, that is no communication. In this alarm, the particular MPC MOP means channel 65 or 66 is not communicating with network channel A and B. In this case, any particular MOP or MPC is not establishing communication either with the network channel A or B. In that case, all action related to this particular component will be terminated. For example, if this is ACU1, it is not establishing communication either with channel A or channel B, then it will stop all the function related to ACU1, like controlling the hydraulic oil pressure, starting or stopping of the blower, HPS pump, receiving data from various sensor, etc. This is actually a serious issue. In that case, any particular affected MPC will be out of the order. In this picture we are going to elaborate little bit more about the single channel no reply and no communication. Suppose this is the CC1 and this is channel number 65 and this is channel number 66. If I take out the plug of channel number 65 or channel number 66, any one from the socket, then I will get the alarm no reply single channel, which will appear on the CCU1. And suppose if I take out both plug, then I will get no communication alarm for CCU1. This no communication alarm means the CCU1 is out of order. Now CCU1 will not take any action. So this is the serious condition. You have to take the immediate action in case this alarm appears. Now we are going to discuss in detail what all possible reasons are there behind appearing of these alarms. If it appears, then check termination resistance, check looseness of wire, check wiring of concerned channel thoroughly, that means network channel A or network channel B. If doubt, do the insulation and continuity test after removing individual section. Fifth, software or hardware issues. please contact Man B&W immediately as this alarm arises. But as far as engine running is concerned, nothing bad will happen because other network is still running. So please be cool and calm. Okay, now we are going to see this next alarm, that is no communication. In that case, check termination resistance, check looseness of wire, check wiring of concerned channel thoroughly, check continuity test after removing individual section. Fifth, software hardware issues, serious issues. Engine will be slowed down in case of CCU, and in case of ECU, EICU, the command will be changed from A to B and vice versa. So if this alarm appears, then you should be very cautious and take immediate action. Till the time this alarm is appearing, there is no as such problem, but start checking all the wiring and try to sort out the issue as early as possible. If nothing is working in both cases, then restart the full ECS system and check. That is the last resort. So our next symbol is not accessible. The simple meaning of not accessible is that there is no problem with network as other MPC MOP are accessible, but so and so unit are not accessible, means issue with the MPC MOP. The simple meaning of not accessible is that network system is not finding a particular MOP or MPC. Our next symbol is online but no information. The simple meaning of this symbol is that there is no problem with the network as other MPC MOP are accessible, but some MPC MOP might be hang or not taking part in communication. That means nothing wrong with the communication cable, only the problem is any particular MPC is not taking part in the communication. In that case, there is nothing serious with any particular component like MOP or MPC. The only reason is that it might get hang, so not taking part in the communication. There is also nothing wrong with the communication cable. Communication cables are intact. This is also a serious problem. If any MPC or MOP is not taking part in communication, that means that particular MPC or MOP will not take part in running of the engine also. So this is a serious issue. In that case, you have to take the immediate action. So now I am going to discuss what all action you need to take. So first one is not accessible. So reason might be MPC MOP is defective, power for MOP MPC is disconnected, cable for net A and net B is removed or cut. Software issues, restart the MPC or MOP. Next is online but no information. Possible causes are means cable is intact, MPC MOP is hang, restart the MPC or MOP. Our next symbol is not applicable, relevant. That is not a serious issue, no action is required. Now moving to next symbol, that is cross connection. So here you know that this is channel number 65 and this is channel number 66. By mistake you can swap this channel number 66 to channel number 65 and channel number 65 to channel number 66 because both are having same construction. So in that case you will get this alarm cross connection. So you can understand it by simple example that suppose I have by mistaken swap the channel number 65 with channel number 66, then I will get this alarm. Normally it should be A and B. After alarm we will get B and A. That means I have to position channel number 65, 66 in their correct location. Now here we are going to see some example related to what we have just discussed, all symbol. Now here you can see no reply single channel alarms are appearing and the counter of the reconfiguration is increasing, whereas net A is okay. This ACRI is basically a MPC and there is a problem of this ACRI to its network channel B. That is why the reconfiguration counting is keep on increasing. How could I make out this? Because by just seeing this cabling map, the alarm appearing over here. Now we are going to see some more example. Now here you can see no reply single channel alarm has appeared for ECU A, but ECU A network B is working fine. Here it is tick, that means there is a issue with network cable A of the ECU. That means I will go to ECU A and I will check its channel number 65. Now let's discuss to this symbol no communication. Here you can see SCU no communication alarm has appeared. So now I will try to check that whether SCU1 is accessible or not accessible. So here I will go in SCU1, then I can see over here that this not accessible alarm is appearing over here. That means SCU1 actually is not connected with the network system, or its power is off, or channels number 65, 66 has gone, or MPC itself is kaput or not functioning. That's what all I can make out by seeing all these symbols. Now what if both channels 65, 66 I take out from the ECU A? Then the scenario will be like this. ECU A both channels will be shown with the not accessible symbol, and that can be checked from the here also. The ECU A both network channel is not accessible, and also here ECU A is not communicating with any other MPC or MOP. So that is all about the symbols, their possible causes and their remedies. Now we are going to see how this sort of alarm appear on the MOP. So here you can see this is the alarm which is appearing on the MOP. Net B not connected to MOP A, like this alarm you will face. So that was a short video for the same. Now we are moving to our next topic, that how to do the continuity or insulation test for network cable. As I have already stated before, that if you find any sort of problem related to network, then you have to do the continuity test or insulation test in order to find the exact fault. So question is how to do. So now we are going to discuss how to do the continuity or insulation test. First of all, I should tell you that all these network cable are divided into segment. That means here from MOP B to EICU B there is a one segment, that is this one for the network channel A. Similarly for network channel B, this is the segment. So if something goes wrong with the network cable, then you have to isolate segment by segment and you have to do the continuity or insulation test. While performing all these tests, one important point I want to tell you, that you can do R&D on one network channel, even SIP is running, but not in port limit, pilotage, etc. So now I am going to show you how we are going to conduct the insulation or continuity test. For that, suppose I have got a alarm related to network A to MOP B. That means network A and network B is all okay to all MPC except MOP B. So I have to check this resistance and this segment. So what I will do, I will just take it out from the socket and I will conduct the continuity and insulation test from this point to this point. So I hope this is clear. So that is all about the network. Thank you for watching this video. Bye bye, take care, have a nice day.